Hi, I'm Joshua Perry. I'm here to present our senior design project, the Pedestrian Lighting Guidance System. According to traffic safety data, most accidents at night occur between 6 p.m. to 6 a.m. That's 70% of traffic accidents, most of which happen between the times of 8 p.m. to 12 a.m. And 20% of those accidents occur at intersections with pedestrians. We believe that this occurs because there's not adequate lighting for the pedestrians to be detected by other drivers for safety precautions. Because of this, we have decided to create an object detection system that can detect pedestrians crossing the street and put a spotlight on them from one side of the crosswalk to the other crosswalk. So without further ado, let's get into the details of our design.
Here is the basis for our small prototype. The two major components are the microprocessor and the microcontroller. The microprocessor is in charge of detecting an image through object detection of OpenCV libraries and communicating through UART the position, the servo number, and the LED to the actual microcontroller. The microprocessor is connected to an infrared camera that brings the camera feed images to be processed, and then through the communications of UART gets transmitted to the microcontroller that receives the servo number, the LED, and the angle, and then transmits that to the servo to change the position and also to turn on and off the focused LED. To maintain proper operating conditions, it must be checked that it is not too windy or too hot. To maintain this, we have two sensors in place. The accelerometer detects if the pole is moving too much, and it will shut off operations if it is too windy for accurate object detection. The temperature sensor will actually monitor if it is too hot for the circuitry to actually operate. For the time being, it is set to 100 degrees Fahrenheit. A small photoresistor is there to maintain the operations of only nighttime. The monitor is displaying the image that is going to be processed from the crosswalk. Here we have turned off the lights to set the setting for nighttime operations. And once we move a pedestrian into frame, his silhouette will be detected and a spotlight will be placed on top of him. As he crosses the intersection, the servo will move to his position based on the capturing of the silhouette. The image is captured and data is sent through UART to communicate with the microcontroller of its position, updating constantly. As he crosses the street, the LED will follow him from one side to the other, and once he finishes crossing the street, a wait time will happen to turn off the LED once inactivity occurs. Now during windy conditions, the servo will shake, causing an emergency lighting system to happen to light up the entire sidewalk on windy conditions so pedestrians can still make it across safely. Same will occur with the temperature sensor. Now a demonstration in full light to fully illustrate the actual demonstration. Our figure is being detected and the LED is tracking him based on full movement.
That was a demonstration of our smaller prototype. In the next coming semester, we will be building a bigger prototype which contains 3 servos, 3 focus lights, 2 cameras, recording at 2 angles with an image stitched together to have a fuller image of both sides of the crosswalk, and much stronger servos. For the time being, this is just a proof of concept, and we will be improving upon our design. Thank you.